right. I think most people are in, so let's start. I'm Mathijs Kadijk. I work at Q42. I do Android as well as iOS projects, but mainly iOS projects. And this talk will be about iOS. And I love to work on open source libraries and tools. Today I'm going to talk about my tool R.Swift. Is there anybody who already knows R.Swift? All right, quite some. Nice. To be clear, it's not about the language R. It's about the R is from the R on Android. I will get back at that in a moment. So R.Swift is a tool that provides strong typed autocompleted resources in Swift projects. Now, you may think, do I need that? Maybe even, what is that? Well, I never thought about strong typed resources myself until I started to program in Swift. I love Swift. We use it a lot at Q42. I think 80% of our actively developed projects are in Swift now. And the language is great. It's concise, it's clear. We have a lot of talks at CocoaHeads about Swift, so everybody knows that. But the main thing I love about Swift is the type checks. There are so many type checks now compared to Objective-C or even other languages that I use. That's really great. The optionals we have, the generics, also the enums that you can use, protocols and protocol extensions, they really help to express yourself really clearly, and the compiler can help you to check many cases beforehand. Even before your application runs, you already know this part of my code is valid and will work. It really gives me the mindset, if it compiles, it works. And I got into that more and more. So what also helps, not only is that we have all those new types, but also we make more and more use of them. So, for example, from a project, I copied this enum. Previously, we might just pass the language on as a string. Now we use an enum, so it's a type that can be checked by the compiler. That helps us catch errors, and you can be sure you're not getting a totally random string that you can't use as a language. Another example is an enum creator from a project where a thing can either be created by a person, and the string will be its name, or by the system. And this makes it really clear what you mean. It can be type checked. You will have compile time errors if you make a mistake. And that's what I like. And what me gets in this, if the compiler accepts it, it will just run. It will work. I don't have any issues on runtime. So I wrote some more code, some real code, like not the example project code, but real project code. And you get into this, like, let's load an icon, the settings icon. Let's get the localized string, the title, from a specific table, a specific strings file. I need to get a storyboard and get a view controller from that, cast it to the right type. Then from the bundle, get some URL, so we can give that to the view controller and do something with it. So that's all nice, great code, and we run it, and the compiler says, okay, this will work, so great. And then, boom, I got this terminating app due uncaught exception, invalid argument exception. Yeah, that's awful. I was totally in the mindset of, well, the compiler accepts it, it's Swift, it will work. No. So this is a classic crash by typo. Yeah, I typed settings with one T, and it should be with double T. So those are awful things, not really nice. Well, you can fix them. And then a colleague comes in and says, well, this code review, that can be way better. Let's refactor everything. So the refactorer comes in, changes the code, changes all kinds of names and IDs and things. And all of those are strings, so none of them are checked by the compiler. And it really made me stop refactoring, basically. I didn't really like changing image names because I would never know if it would turn up somewhere in the app as just a non-loaded image, just a nil. The app wouldn't even crash, so I wouldn't get a crash report. Although I don't know if that's better, but anyway, I'm not really certain about if this will work or not. And this made me wonder, how do they do that on Android? So I took a peek over the wall and thought, well, what do they do? How do they load resources? How do they reference to them? And they have something called R, the resource class. For those who are iOS-only people, in Android you can type r.drawable.settingsIcon, and you have the reference to the settings icon. You can use that to load it in instead of the string. There's also for strings files, there's also r.string, and there's also r.id for things like views and view controllers to reference to them. And those are automatically generated, so you don't have to do anything for them. It's just there. It's compile time checked, so if you change an identifier, the generator will run again, and your code will just break, so you have a compile time error. It's also autocompleted, so you just type r.image. And then you pick the image you need. So that's quite great. I like that a lot. So I thought, I want that on iOS. I like that. I want to have that. So, well, I created R.Swift. It's an open source project. It's on GitHub. So we use it already in a lot of production projects for the PostNL app, for example, the app for Staatsloterij, and also the Tate Gallery from London. We also created an app for them, and R.Swift is also in there. So it's used in quite some Swift projects. And it has a decent amount of stars on GitHub. So let's refactor the code we just saw on the slide to the R.Swift style code we then also could use. So here's the code again. Now, first let's change the UI image on top to the R.Swift style. R.Swift generates the same kind of structure as the Android R does. So we can type r.image.smallgear, and it will return a UI image. So this is exactly the same as the UI image variant, only this is auto-generated by R. So it will be auto-completed for you, and when you change the name of the icon, this identifier will be not longer there, so your code will break and you will get a compile error. We can do the same for the localized string. So here we have r.string.settings. Setting is again the table name, and then .title, and we'll get back the title. And then we have the instantiation of the view controller there. We can change that whole loading of the view storyboard, instantiating of the view controller, and the casting with this line. And R will do the casting and loading of the storyboard for you. And then we have the URL at the bottom. And we can also change that to this. All the resource files are also known to R, so you can also reference that from here. So you see this is a lot shorter also, so it's less verbose. All the strings are gone, so there is no more string identifier that you have to use that will break your app at runtime. And also the cast is removed, so you don't have to know what type of class that initial view controller is from the storyboard. R also loads that from your view controller at compile time and will do the cast for you. One thing to note is R will never force cast anything or force unwrap anything, so your code will never crash. So if Apple returns a UI image optional at the first line, R will also give you the optional. And if you want a non-optional, then you have to do a force unwrapping. So R will always be safe, and you have the choice if you want to force unwrap anything or force cast anything. So time for a little demo. I've prepared a little demo to show it in action. I think that's the best way to see what it will do. So I've created a little app here. If I run it, then we can see what we have. I hope it will pull me away to the simulator. Oh, simulator needs to boot. Great. So I've created a super small, tiny demo app. And this app consists of 2 screens. There's a welcome screen, which is here, which is now launched in the simulator. And there is a little table that shows the location of some people. It's all demo and fake, so it's just for demoing the R.Swift purposes. So the first thing I want to do is this screen is a little empty. I want to add the logo of my company in here. So here's the simulator. Let's go to the welcome controller that we just saw in the simulator. And here we have a little to-do. We have to insert the big logo here. So now I can say r.image. And then I want the big logo and load it in. So here I have an autocompleted image, and R has generated this struct that is autocompleted. So now I'm done. I can rerun it, and it will just load in the Q42 logo. There it is. Super beautiful. All right, then there is this dummy title here. I want to replace that with the real title of the button. So I can do r.string.general, which is the table, .start button title. So this is quite simple, but it's really convenient that it's auto-completed. If anyone changes the name of anything of this, it will just break compile time and give me an error. So I don't really like the big logo name. So let's go to the assets catalog here. Look for the logo. And I'll rename it to Q42 space logo. Now I'll build again. And I'll get a compile error. So this line errors and says, well, this is not correct. Big logo is not correct. And if you're lucky, Xcode will sometimes generate a replacement, but most of the time it won't. So let's just edit it by hand and say Q42 logo. So even though I typed in Q42 space logo, which isn't a valid function name, R.Swift will repair that and create a valid function name for you. So most of the names you already have in your project will just work. Well, there's another weird image name. This should build now. There's also a carbon heads logo. Well, that's incorrect. So let's rename that to CocoaHeads. Cool. Then I build again. And the build just passes. This is because the CocoaHeads logo is set in the storyboard. It's right here. So now my storyboard is broken. R.Swift can't validate that on runtime, but you can put something in your test, like here. There is an r.validate method that will throw at runtime an exception. And what the r.validate method does is validate all your images, all your segues, and a bunch of other stuff at runtime. So I've created the test here, and when I run the test, you will see the build succeeds, then it's testing. And now the test fails, and it says image named carbon heads is used in storyboard main, but couldn't be loaded. So now it tells me, like, all right, in that storyboard there's an image that doesn't work. And we just run the test in our build server, and it will tell us, like, okay, you've missed an image in the storyboard. So now I can correct it, just like you normally would. There it is again. Run the test again, and it will be green. Yeah, sure.
So the validate function, does that like load every view controller in your storyboard?
Yeah.
And then like instantiate that and see if that loads any resources that will exist?
Exactly. It will loop over every view controller in your storyboard that has an identifier, loads it, and it it just does UI image named for every image it sees in your storyboard. So it basically loads everything. So you really should do this only in a test and not in production code, because it is, if for bigger projects, it's really slow, or really slow. It will take a few seconds. So that's something to be aware of. It's really test code.
Yeah. What's the reason? But you could build something where you're at compile time, you're already generating your strongly typed view controller, so you get the images from there, and then at the end check. Oh yeah, is everything there?
That's correct. But the thing is, R.Swift at this moment has no knowledge about your code. So I don't know if you've made a mistake, for example, with saying that a certain view controller is of a certain class. If you make a mistake there, that's really hard to know for R.Swift at compile time, because then it could be done. But then I need to have knowledge of all your code, including all the CocoaPods you're using, all the other modules that are included, and still the Objective-C runtime is below it, so everything can be dynamic. So I'm never sure if it's there, and the compiler will just assume it will be there at runtime. So that's why this runtime method is there. Then it is just always correct. But it would be more convenient if you could do it at compile time.
Sorry, another question. What's the reason you're calling these resources as a function and not as a property?
Yeah, that's a good one. That's because if I dive into the generated code now, we have specific types for things. Like there is a LED Q42 logo, and that's an image resource, which is a type that the R.Swift library contains. And you can pass this image resource around. So you could, for example, also extend this image resource with protocol extensions. And that gives some powerful things you can do with it. Yeah, but that's more the advanced stuff. Like you could say, well, if there is a view controller or there's a table cell that also has an identifier, then I want to create an extension method on that. So there's really cool stuff you can do, but it's quite advanced. But if you're into that, that's really nice.
But nothing prevents me from using that property.
No, you may use that property.
Every time you type in a name, you see the property and the function.
Yeah, and you can choose, because I could first save. So I could do logo r.image.q42 logo, and now I've got the image resource, and then I can say, all right, get me that logo. So you can pass the image resource around in your app, and you know that it's valid.
You need to disable Flux.
Yeah, Flux is kicking in.
What's your reason behind this? I had the same question, but I wanted to wait till the end.
Yeah, let's do that one in the end. So this is more advanced stuff, but we have. Let me refer that. So now we've loaded the logo, we've loaded the string. Well, that's great, pretty simple stuff. But we also have the start button there, down here, and that's not doing anything. So that's not implemented yet. So let's now perform a segue. So I can say perform it's Swift 3, so perform autocomplete is not helping here. Oh, here it is. Perform segue, yeah. So r.segue, it also detects the segues that we have in our our storyboard. And then I want the segue that's on the welcome view controller to the location overview. And the sender is self. So that's it. Now I've called the segue. And when you update the identifier, it will also again update here and just break your code. So you can just refactor that. Then, of course, we have to prepare for segue that we have to implement. So let's do that. Then we say first we now have the segue from Apple. So the first thing we have to do is check, is this that one segue that we have invoked? Normally you would check the segue.identifier string, but I don't want to check any strings. So I do if let segue is r dot segue dot welcome view controller dot to location view. So that's that same segue again. Then I pass it the Apple segue. And now what it will do is it will check the identifier. It will check if all the destination and source view controllers can be cast to the correct type. And if that's possible, then it will return it. If it can't, then it will return nil. So now I know I have the segue.
You're missing the parameter name.
What I'm doing wrong. Let me peek.
If let segue, yeah. If let segue, it's a different kind of type. Say you're using the same as the parameter.
Yeah, the parameter.
A segue or something like that.
Yeah, it should be allowed. I think it's something else. Let me see. Oh, wrong one.
Yeah, segue.
Oh yeah, it was what Niels said. All right. But I didn't get that until I pasted the... Thank you. All right, so... Now we have a type segue there. Then I do segue.destination. That will be the destination view controller. And that's cast to the correct type. So now I can say username, which is a specific property on the destination view controller, without me having to cast that thing. So there are no strings involved, no casting, and I can just use that, and I can say username, well, Mathijs. All right, so that's it. So now I can run that. There it goes. Hit the button, and it will just perform the segue, and it has put my name in there. So that's quite nice. So that is using segues without any string identifiers or casting yourself anything. And it's just a normal storyboard, configured regularly, nothing strange there. So that's that. Then on to the next controller where we land. Well, here's some stuff. And this is a regular table view controller. Nothing fancy, no protocol extension magic, just a normal UI table view controller from Apple. The first thing I have to do is register my nibs. On the left here I have two cells, an Amsterdam cell and a Den Haag cell, that are the location of our offices. So I want to register them with the table view. So I have to type table view.register nib. And then I have an overload where I can pass the R.Swift version. So I can say r.nib.amsterdam cell. I also want to register the Den Haag cell. So r.nib.Den Haag cell. All right, so now I've registered those two cells with the table view. And later on, over here, at the self row at index spot, I can use their identifiers, their string identifiers, to dequeue them from the table view. But again, I don't want to use the identifiers. So let's implement this one. I have a little items array here down here with two types of items. So an Amsterdam location and a The Hague location. So the first thing I want to do is switch over the item at the index spot row. So I'll fetch the item. I'll do a pattern match, Amsterdam photo, and also the Hague version. And this is the the method someone wants to use to get at the correct level of the building. All right. So then I say, then the first thing I have to do is get a cell from the table view. So cell table view dot DQ reusable cell, and then I have to give it the identifier, and there are also our reuse identifiers here. So I'll get the Amsterdam cell reuse identifier, and I pass in the index spot. Now this will return an optional. I don't want the optional. I just force and wrap that. Then I do a cell.left aligned name label, and that's something that's specific for the cell. So the Amsterdam cell has a left aligned name label, and I want to do text, and then I'll put something random in Amsterdam. Oh, I don't want that. And I'll return the cell. Well, same trick for The Hague. Let cell is table view dot DQ reusable cell. I'll use the other identifier, so Den Haag cell at index spot cell dot, and here I have a right aligned label. So, and to prove it, I can say cell dot right aligned label. It's not there on the Amsterdam cell. So what R.Swift will do is DQ the cell from the table view, and then cast it for you, so you can use it and then return it. So dot text is The Hague, and let's put in a method that we use. I don't use the photo. Return cell. Also should force and wrap this one. All right. Let's see.
So the DQ reusable cell is your own method.
It's an overload. Yeah. So R.Swift has a lot of overloads. So you can mostly use the method you know, and then there is an overload that doesn't take the string, but an R.Swift type, a resource. Yeah. So let's see if it runs. Yeah, I know. So there it goes. And there it is. So then it just loads it up, and it's there. So no use of string identifiers there.
Why does it return an optional? If it's certain that it's...
Apple's implementation of DQ reusable cell is returning an optional. So even though I'm pretty sure it will always return something, I'm not 100% sure that Apple's implementation will do that. And that's one of the principles of R.Swift, that it will never force and wrap anything for you. Because I don't want to create a situation wherein your app crashes. So I'm pretty certain that...
Yeah, I had to do a if let again.
You may not have registered this particular identifier, right?
Yeah.
Yeah, exactly. So it could be, I can still forget to do the register up here, like this.
And then, okay.
And now it won't DQ, because that's a decoupled thing in Apple's APIs.
And now it will crash on your...
Now it won't, yeah.
Force and wrapping.
Exactly.
Cell, right? Yeah.
So I also could code more defensively and say, no, I'll do an if let again, and then maybe handle the situation wherein I made this programmer error. Here now it's crashed. So that's why, and it's crashed on the exclamation mark I typed. So the tool will never crash your code. You will do it yourself.
You're 100% sure.
99% sure.
Standard
It's high. I do a lot of tests. But you're really welcome to submit an issue on GitHub, and I'll promise I will look into it if you have a crash caused by R.Swift. So that's basically the demo to show you. And for example, the segue here, it's just a regular segue, and I've put the identifier in here, and that's all picked up by R.Swift. So those are all things. If I start to change them, R.Swift will again give me errors. So back to the presentation then, a few slides ago. let me take the mic again. So that was the demo. So the benefits are R.Swift will fully type anything it knows the type of. It will do compile time checks for you. If you change an identifier, the compiler will warn you about it. And as you saw, it's autocompleted. We support a wide range of resources. R.Swift will detect images, custom fonts, resource files, reusable cells, localized strings, storyboards, segues, and nips. So all of those things are supported. All on iOS and tvOS. And I hope I will someday create watchOS support and macOS support, maybe even. But that's just a time issue. The principles I already talked about. R.Swift will never crash your application. We will always choose the safe side of things. R.Swift will always compile. So if we, for example, see two identifiers with the same name, we have to choose which one to use. But R.Swift will not make that decision for you. It will emit a warning and will just output the file without that one identifier. So that, again, is a safe choice, and you can then solve that warning by changing the identifiers. And clarity over brevity, and that mainly means that we always will stay close to the Apple APIs and create an overload that is exactly the same, but then with an R.Swift identifier. Installation, something I didn't show and talk about. You can just use CocoaPods, then it's just pod install, and you have to add one thing to your build steps. So then you add the build step where R.Swift will generate the file. You can also do it manual if you don't like CocoaPods. That's more work, but hey, you choose it yourself. So there is an instruction in the README. There are also alternatives. SwiftGen is the biggest one and the closest one to R.Swift, also properly maintained. Natalie's is also one, but less maintained. And R.M is an interesting one we just discovered. Tom in the back there discovered it yesterday. And that's an R.Swift-like thing, but then for Objective-C. So if you still have to use Objective-C, that may be interesting. It's rather small, but interesting thing. So what's the main difference between those alternatives, or mainly between R.Swift and the alternatives? R.Swift looks at your project file. So it reads your project file, and it knows about the targets you use. So even a complex setup with multiple libraries, multiple targets will work. We use it ourselves in our projects, and it just works fine. All the other alternatives, there you have to put in the files yourself. So you're telling, here's my storyboard, please parse that one for this target. So they won't read your project file. And R.Swift just works. So there are sane defaults, and they should never interfere with your project. Just had a bug report about one interference, so we have to fix that. But most of the time it will just work. The other alternatives have a lot of settings to prevent conflicts and multiple templates for things you like. I don't really like that, but that's more of a personal thing. One other thing, a maybe alternative is like image literals. Some people have been asking me like, well, Xcode 8 also had has image literals. You just saw one autocompleted. Well, to be honest, image literals suck quite a lot, because what it does is basically the UI image named in another way, and it force unwraps the image at the end. So what happens if you insert an image literal and then rename the image? Then Xcode will just compile. It will just run the app, and once it tries to load the image, your app will crash. So with UI image named, it would just return nil, and you don't see the image, but with the image literal, it will crash your app. So when I tried that at WWDC, I was very disappointed that it made things worse instead of better. So that are mainly the alternatives, and that's a brief overview of R.Swift. I hope you liked it. If you have any questions, you can come to me or to Tom. He is a great maintainer of the R.Swift project in the back there with the camera. And we're happy to answer any questions. Thank you very much. Any questions? Yeah, sure.
You didn't show any R. Is it the language? How do you I'm not an Android developer, so I have no idea what it looks like. I only know the language R, which is something completely different.
Yeah, the R language has nothing to do with this.
So how do you define all these things?
Yeah, what happens, I can actually show you just a generated file. So what happens is you add a build step to your project, and then the build step is here. So you have build phases, and there you add one manual build phase. That's this line. Then the R.Swift tool will run every time you hit build. And it outputs this file. So there's an r.generated.swift file. You add that file to your project, and it generates a struct. And that's all it does. So what it does is it parses your whole project file, then it generates Swift code, outputs it into a file, and then lets the compiler do its job.
Same with the strings file, for example.
Basically, yeah.
Does it always do everything that it can put in the generated file?
Yeah.
So no selection, okay, I only want strings.
Not yet. There's a feature request on GitHub, and I think I'd like to have some disable flags, so you can say disable strings, for example. So, yeah, it's on the list. I'll have to take a pull request.
Do you know if you can if-let image literals? Like if they are forced and wrapped, you maybe can if-let.
I've not tried that. Would be interesting to see if you code if-let it. So maybe. Yeah?
So you mentioned that R.Swift also works with complex setups with multiple frameworks. So does it generate a file per framework then? So each framework has its resources?
Yeah, that's correct. So you would add that build step to every framework you create, and every framework or library has its own generated file. Currently, those are internal, so they're you're not exposing the resource to other libraries. That's another thing that's on the list, like maybe you should be able to configure that. Also, one thing to mention is that the resource, this generated file is aware of like things of bundles, etc. So it will always load the file from the correct bundle. So we first had some bugs with that, and it's rather complex if you have to load the correct resource at the correct moment, but that's all solved by R.Swift. Yeah?
Will you generate errors if I didn't put in the right target?
No, you won't get an error. Well, if you mean by target, the compilation target, if you mix that up. So yeah, debug and release are not really targets, they are schema configurations, but the only thing you can mix up is drag the generated file from your app into a library, for example. Then you're just screwed. I won't check that.
I have another question. How much time it will take for a really big project to generate this file every time on every boot?
So we're using this in like the PostNL project, and I think it takes about 1, maybe 2 seconds there. So that's about the timing for quite a big project. So I don't mind it running.
The amount of resources that you are defining on each project, right?
Yeah, it depends on the amount.
How many images you have on the resource files, how many texts and labels you have on the localized files, etc., etc., etc.
Yeah. But if you have a case where it's slow, I would really like to know that, because I have some open branches with doing things in parallel, but it's just too much work for too many or not enough
Chain operations, maybe?
Yeah, so there are some optimizations that we can do. So if it's slow in your project, let me know. Yeah?
Since it relies heavily on identifiers being set, the strings, do you have a way in place to actually check your storyboards, whatever, for missing identifiers, or empty identifiers?
No, we don't have that at the moment. So if you set an identifier, then we'll validate it and check it. If you don't set an identifier, that is a valid case. I have a lot of, for example, view controllers in a storyboard that I never give an identifier. So there's nothing for that to check that. But if there is an interesting use case, then I would like to hear about it, because it could be interesting. Yeah.
You showed the storyboard segue thing, right? Is that a property and a function that has the same name?
Yeah,
or,
correctly.
Yeah, exactly.
Yeah. And there's a little bit of an interesting thing there, because you can't name a property and a function the same without that function having an argument. So I give all the functions an argument of underscore void, and then it will work. Yeah?
So we had a similar thing in my previous job. Like we had the Suna Python script. We just had a static. We would just generate like static strings or parsing the whole XML of the storyboard thing. And so my question, like for this to make work, you have to like whenever you're making changes, you have to do a build pass, and then you see that the auto-generated file, and then you see the things in action, right? But if your project is like really big and your compile times like takes, I would say, 3 minutes, then it's like a very painstaking thing. Right? You make your changes, then you compile, then it generates this R.Swift.
Actually, the PostNL project takes a lot of time to compile, like 20 minutes or so. Or clean build is maybe even 30 minutes on a slow machine. So that's crazy. There's a whole other Swift compiler problem that we have. But yeah, that's painful. But what you can do is hit the build button, then just terminate the build, and then the generated file is generated again. And then your auto-completion and the Xcode inline errors will all update probably. Because it's Xcode.
Thank you very much. Sorry to
yeah.